Hello everyone. So in today's lecture, we'll be looking at how we can perform independent sample t-test. So we have seen in the previous lecture that under compare means we have 6 statistical techniques. And independent sample t-test is one among the statistical techniques under compare means. Now, compare means is a test we will perform when you have a categorical independent variable and a continuous dependent variable. So categorical means nominal or ordinal scale. So independent variable can be either of these scales, and your dependent variable is continuous in nature, which means it is either ratio or scale. So now, independent sample t-test, whenever you perform this, you need to keep in mind few assumptions. The first assumption is that you're comparing only two groups over here. So your independent variable, that is categorical in nature, can only have two groups. For example, gender, where we'll mostly write males and females. So you can compare such groups. For example, marital status, which is married or single. Again, we have two groups. So for these, you can perform independent sample t-test. The second assumption that you need to keep in mind is that the dependent variable is continuous in nature. So your dependent variable, you should see that it is either in your ratio scale or your scale. The third assumption is the dependent variable is that the dependent variable is normally distributed within each category of the independent variable. So here we have to test the test of normality that we will be seeing later on. And the last assumption that you need to keep in mind is that you have similar variation within each category of the independent variable, where we're testing the homogeneity of variance. So what is this homogeneity of variance? Homogeneity of variance, here in SPSS, we will see the results of Levin's test for equality of variances, which helps us to assume the homogeneity of variance between the two variables. So this particular test determines if the variation is similar or different between the groups. So again, if we have to write the hypothesis for the homogeneity of variance between the two variables, then we'll write for null hypothesis that there is no difference between the homogeneity of variance between the groups. They are similar in nature. And for alternative hypothesis, we'll write that there is a difference in the homogeneity of variance between the groups. So now, when Levin's test is not statistically significant, how will we say that it is not statistically significant? We will say this when my p-value is greater than 0.05. So when the p-value for Levin's test is greater than 0.05, it means that we can continue with the regular independent sample t-test, and therefore we will look at the row where the value is equal variances are assumed. So please kindly just understand when you have to see equal variance assumed and when you need to see equal variances not assumed. Once we do the analysis in SPSS software, again we look at that particular table and understand this concept in a better way. The second thing that we need to remember is that what happens when the Levin's test is statistically significant. Again, statistically significant, it means when the p-value is less than 0.05. So when the Levin's test is statistically significant, it means that there are differences in variation between the groups. So we will see the row which has equal variances are not assumed. So we will see that particular row for the values. So just to show an example of how your output will look like and what do I mean by those concepts of Levin's test not being statistically significant or being statistically significant, which row do we need to look? So you will see the first here column is the Levin's test for equality of variances. So here you'll see equal variances assumed and equal variances not assumed. And you have the significance value, which is nothing but the p-value. So you will see this value, and if it is less than 0.05, you will see equal variances not assumed. Because when it is less than 0.05, you will accept your alternative hypothesis, which says that there is a difference between the homogeneity of variances between the two groups. Therefore, we will see equal variances not assumed. But if your p-value, the significance value is greater than 0.05, in this case, we will see equal variances assumed, which means the null hypothesis which states that the homogeneity of variance between the groups are similar, are the same. There is no difference. So therefore, we will see equal variances assumed. So this is how we will be looking at the Levin's test for equality of variances. So we will perform in the next lecture, we will be performing the same test in the SPSS software, and we will see to how we can analyze and interpret this particular table that we will get in the independent sample t-test. So that's all for today. Thank you.